Hey everyone, welcome back to another Edexcel IAL Maths past paper video. Today we're going to talk about the S1 Statistics 1 exam from the October-November 2024 series. So let's jump into the paper. The back-to-back stem and leaf diagram on page 3, this one, shows information about running times of 31 action films and 31 comedy films. The running times are given to the nearest minute. Write down the modal running time for these action films. Okay, the action films are on the left side. Modal means we need to know which one occurs the most. So if you glance through it, this is 137. If you read through it, this means 90. So this 13 times by 10 plus 7, that means 137. And this is twice, this is twice, this is twice. That means the 3 times it is occurring, that is 137. So the modal time is 137. For these action films, find one decimal place, the mean running time, and the standard. Oh no, sorry, no. Some of the quartiles for these two distributions are shown in the table below. The lower quartile, median, and upper quartile. Okay, some values are missing. Find the value of A and the value of B and the value of C. Okay, so we need to write the median of action films. Okay. So let's action films were in total 31 and 31, right? Okay, so 31 and 31. So for median, action films, Q2, the location can be found from doing n plus 1 divided by 2, 31 plus 1 divided by 2. This would be 16th location. So the Q2, or in this case, it's B, would be. So let's figure this out. So 1 plus 0 plus 5, that means 6th. 6 plus 10, 16th. So that means 16th is 129. But let's count it anyway. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 129. Right, okay. Then we have lower and the upper quartile of comedy films that we need to figure out. Okay, so first we need to figure out what the Q2 is. Q2, they give us 117, but the one, okay, so this is our Q2, right? So basically what we're going to be doing now is we're going to be splitting 15 backwards and splitting 15 after. This one, the Q2 for comedy films, that is now unavailable. So for 15, for comedy films, Q1, which is A, we need to figure out where this lies first. So 15 plus 1 divided by 2, that means 8th location. 1, 2, 3, 4, 5, 6, 7, 8. And this is 106. Therefore A, which is Q1, is 106. Similarly, 8th position from 7, 1, 2, 3, 4, 5, 6, 7, 8, 126. Q3, which is equal to B, wait, C, that is equal to 126. All right. For these action films, find to one decimal place the mean running time and the standard deviation of the running times. Okay, you may use the sum of x 416 and this to be right. Okay. So they have made things easy for us. So part 1, mean would be the sum of values of x over n, and they give us 416 divided by 31. So 416 divided by 31 is 129.5. So since we need the 3 significant figures answer, so we can write it as 130. Right, now we need the standard deviation. So first we can begin by finding variance, which is sum of x squared over n minus the square of the mean. So they gave us this value, sum of x squared 525056. 525056 divided by 31 minus the square of this value. Right, so let's calculate this. So you have 525056 divided by 31 minus answer squared. This is our variance 506. Since we need the standard deviation, this would be square root of answer 12.4. Okay, all right. One measure of skewness is found using mean minus mode over standard deviation. Evaluate this measure and describe the skewness for the running times of these action films. Right, okay. So, right, okay. D part. So, skewness. Mean minus mode. Mean was 130 or 129.5 minus mode was 137 divided by standard deviation 12.4. Let's use one value more. So actually 1430 12.4. Okay. Since like in the working we can use higher values, like higher accurate values, minus 137. No, sorry. Not minus. This is plus. And 12.43. This becomes this negative. So minus 0.603. So this is slightly negative. So we need to describe the skewness. So we just need to like describe it negative skew basically. So negatively skewed. Right, okay. Let's see the next part. Comment on one difference between the distribution of the running times of these action films and the distribution of the running times of these comedy films. State the values of any statistics you have used to support your answer. Right. So we can use, since this is just 1 mark, they don't need to know the skewness of this because we would have to calculate the mean, mode, and standard deviation of the comedy films, but we can use the median and interquartile range, and the range also basically. So we can comment on these. So first, let's figure out. So A was 129. No. This was 129. A was wait, where did it go? 106 and 126. So 106, 126. So basically you can see that the spread, let's find out the interquartile range also, IQR. So 138 minus 121, 17, and 126 minus 106 is 20. So interquartile range of comedy films is slightly higher, but the median of comedy films, the median value of running time for comedy films is lower, right? And the other one was range that we could discuss. So range of action films, sorry, where did it go? Is from 90 to 147. Okay, so 157 basically. And on the other side, 92 and 131. So 131 minus 92. Wait a second. Oh no, sorry, 57. 39. Let's calculate. Maybe I made a mistake somewhere. Why did I write 157? 90 and 147. Oh, okay. 57. Right, okay. So the range is higher for action films. So we have now three statistics to compare with. So we can say the median running time for comedy films is higher than that of action films. The median comparison was 117. Oh, no. Median. Oh, sorry, no. Action films was higher. So, okay, is lower than that. Okay, let's call it lower than that. So 117 is lower than 127. I hope I used the numbers correctly, because 129 and 117. Okay. Then we can comment on the interquartile range and the range. Whereas the range for come on man, I just need 57 and 39. Range for running times of action films is greater. 57 greater than 39. You can also say the interquartile range for action films running time let's say, what was it? Slightly smaller. Slightly smaller than that of comedy films. 17 less than 20. Okay, so we have actually given three statistics, and I think we only needed one, right? Okay, so we can use in the exam we can use all of them, but at most we just need one of them. Alright, so that's it for the first question. Let's move on to the second one. Question number 2. A biologist records the length y centimeter and weight w kgs of 50 rabbits. The following summary statistics are calculated from the data. Okay, show that SYY is 734. So SYY, which is related to the variance of the y variable, is sigma y squared. You can check the formula booklet for this also. However, you need to learn how to memorize these also. You need to memorize these for faster processing. Sigma y squared is 819. Let's first write over here 38.5 minus the square of 2015 divided by 50. Okay. No. What am I missing over here? 819. Oh, sorry, no. Sorry, this is squared. I keep mixing it up with variance divided by 50. 734, right, okay. So 819, 38.5 minus 2015 squared divided by 50, that is indeed 734. Calculate the product moment correlation coefficient for these data. Right, for product moment correlation coefficient, or R, either way you can write it as product moment correlation coefficient, you need the covariance of WY divided by, or YW, whatever you want to call it, then the square root of YY and WW. So one of these we already calculated, but for the other two, 219.55 divided by SYY, we calculated it to be 734, and SWW 72.25. Right, this, and we need to just simply calculate 219.55 divided by the square root of 734 times by 72.25. This is coming out to be 0.953. Interpret your value of the product moment correlation coefficient. So basically it's a positive correlation. So we will say longer the rabbit, heavier its weight. Simple interpretation. The biologists believe that a linear regression model may be appropriate to describe these data. State with a reason whether or not your value of the product moment correlation is consistent with the biologist's belief. So yes, it is, because we actually got the value of 953, so 95% you could say, so it is closer to 1. So a linear regression model would be appropriate as the PMCC value is close to 1. Okay. Find the equation of the regression line of W on Y, giving your answer in the form W is equal to A plus BY. Okay. So we need it in this form. So this is our gradient and this is our y-intercept. So this is just S covariance, so YW divided by SWW. No. This is YY. This is YY, right. So this one was covariance 219.55 and 734. 734. So 219.55 divided by 734. This would give us 0.2991144. Now I'm writing a higher value because we still need to calculate a few things. So so we know that line actually passes through the mean of W and the mean of Y. So when we plug in, you will get A is equal to W mean minus B Y mean. That means W was 125 over 50 and B 0.2991144, and this is 2015 divided by 50. So answer 125 divided by 50 minus answer times by 2015 divided by 50. So you get minus 9.554311. Now we just need it in 3 significant figures. So minus 9.55 plus 0.299y. Jeff has a pet rabbit of length 45 centimeter. Use your regression equation to estimate the weight of Jeff's rabbit. Okay. So we have the model. Length is equal to 45 centimeters. So W will be minus 9.55 plus 0.29945. So minus 9.55 plus 0.299 times by 45. So this is therefore 3.905. And that's it for this question. Let's move on to the next one. A group of 200 adults were asked whether they had read cooking magazines, travel magazines, or sport magazines. Their replies show that. Using this information, complete the Venn diagram on page 11. Alright, so I've already pasted it over here, so let's dissect it. So 29 read only cooking magazines and nothing else. So 29 would be here. 33 read only travel magazines, 42 read only sport magazines, 17 read cooking magazines, sport magazines, but not travel magazines. So this would be over here, 17, right? And 11 read travel magazines and sport magazines, but not cooking magazines. 22 read cooking magazines and travel magazines, but not sport magazines. Okay. 32 do not read cooking magazines, travel magazines, or sport magazines. So 32 would be outside. Now there's only one thing left. The total number of people were 200, right? So we just need to subtract all of them. So 29 plus 22 plus 33 plus 17 plus 11 plus 42 plus 32, 186. So 200 minus 186 is just 14. So there you go. Okay. One of these adults was chosen at random. Find the probability that this adult reads cooking magazines, travel magazines, and sport magazines. So we have already calculated the value. B1 would be cooking magazines, travel magazines, sport magazines is 14 over 200, so 7 over 100, which is 0.07. Second part, do not read cooking magazines. So everybody other than do not read cooking magazines. Does not read cooking. Oh no, sorry. Does not read cooking magazines will also include these ones also, because they do not read either that also. So do not read cooking magazines will include 42, 11, 33, and 32. So 42, 11, 33, 42, 11, 33, 32, 200. Just to make sure that that's what we have. 42, 11, 33, 32. Okay. It's 42 plus 11 plus 33 plus 32. 118 divided by 2. This would be 0.59. Okay. Given that this adult reads travel magazines, find the probability that this adult also reads sport magazines. Now this is a conditional probability. The condition is that this reads sport magazines given that he also reads travel magazines. So using Bayes' theorem, you have S intersecting with T divided by probability of T. Okay, so basically like a fraction of the traveling ones, how many of them also read sport magazines. So right, so this would 11 plus 14 divided by travel. 11 plus 14 divided by 11 plus 14 plus 33. There was one more I forgot. 22. So this would be 11 plus 14 is 25. So 25 plus 33 plus 22. 80. So 25 divided by 80 can be further simplified to 5 over 60, or you can write it as 0.3125. Even like that would be the exact answer if you write it in fraction form. Right, okay, so this was question number 3. Let's move on to question number 4. Question number 4. The distance is m miles. Motorbike travels on a full tank of petrol can be modeled by a normal distribution with mean 170 miles and standard deviation 16 miles. Find the probability that on a randomly selected journey the motorbike could travel at least 190 miles on a full tank of petrol. So what we have, let's first write it out. So distance is m miles, is normally distributed, mean is 170, and variance being 16 squared. Right, okay. We need probability m being greater than 190. Okay, so first we need to standardize it. So standardized form would be 190 minus 170 divided by 16. Basically like the x minus mu over sigma not 6. So we are getting the value z greater than 20 divided by 16, 1.25. Right, and we know from bell curves or the normal curve that this is 0, and 1.25 would be somewhere over here. So we are looking for this area, but we can't find this area. So what we will do, we will subtract it from the less than part, 1.25. Now let's go to the standard normal table and see where we are. So 1.25, the phi of 1.25 is 0.8944. So let's go back to the paper. Right. So this is 1 minus 0.8944. So 1 minus 0.894, sorry, minus, you get this value, 0.1056. You can round it up to 106. Right, okay. The probability that on a randomly selected journey the motorbike could travel at least d miles on a full tank of petrol is 0.9. That means still greater than that. Find the value of d. Okay. So probability m greater than d is 0.9. So first let's figure out what value of z value it corresponds to. So the z value, sorry, this would be still, we will handle it the same way. Probability of z less than z is equal to 0.9. So therefore the value that we are looking for is 0.1. 1 minus 0.9. Right, okay, so we just need to go back to the table and see where 0.1 comes. Actually, you can see this in this particular table also. So we need a value greater than z. So we need probability 0.9, sorry, no, 0.9. So as you can see, this is going to give us the same value because 0.9 and 0.1, the area greater than that would be identical. So go back to the paper. Actually, we can find out the same value if we use a little bit of linear interpolation also. So 0.1, we need the value less than 0.1, but we can't have it obviously because 0.1 is less than 0.5, so we still need the 0.9 for that. So how can we know this? Because you see 0.1 means the area is less than 0.5, so that means that what we are looking for over here, 0.1, A is actually itself less than 0 because we're talking about the standard normal now, right? So what we would handle it is by just simply doing 1 minus z less than A, which would be the positive one. So 1 minus 0.1 would still be 0.9, and what we're looking for is 0.9 instead. So 0.9, let's look at 0.9999. Okay. So it's somewhere in between. You can do a little bit of linear interpolation into this. So let's do the linear interpolation. So 0.9 minus 0.8997 divided by 0.9015. Actually, this is not a linear function, but still we can approximate it, linear interpolation over here. So this is 1.29 minus 1.28 x minus 1.28. So let's do that. So 0.9 minus 0.8997 divided by 0.9015 minus 0.8997 times by simply 0.01, right, plus 1.28. So as you can see, 1.28166 is exactly the answer. Z value is what we had exactly as before. So even over here, we have the same value. So 1.2816, the same value. Right, now going back to the paper. So Z is coming out to be 1.281667, and this is equal to what was it? X minus mu, D minus mu over 16. So answer times by 16 plus 170. So D is 190.5067. So roughly 191. Right, so this would be our answer. Right, so this is question number 4. Let's move on to question number 5. Question number 5. The histogram shows the number of hours worked in a given week by a group of 64 freelance photographers. Give a reason to justify the use of histogram to represent these data. Because time is a continuous variable. So it's not a discrete variable, it's a continuous variable. Time, since time is a continuous variable, the use of histogram is justified. Okay. Given that 16 of these freelance photographers spent between 10 and 20 hours working in this week. So basically, remember, the area corresponds to area under a bar corresponds to the frequency. So they have given us the frequency under this bar. Estimate the number that's spent between 12 and 24 hours. Okay, so basically this gives us an insight into the scaling of the frequency density. So 16 if worked. So 16 is equal to frequency density times by 20 minus 10. So frequency density is going to be just 1.6. So we go back and make a note that this is 1.6. So this means that this is 1.5. 1, because as you can see this is 0.1 now, so we can make judgments. 1. This is 0.5. 2, 2.5, 3, 3.5. So we can say this is 2.7. No, sorry, 2.8. And this one we already calculated, deduced it to be 1.6, and this one is 3.4. Okay, now we need between 12 and 24 hours. So 12 and 12 is in between this, and 24 would be over here. Okay, so we need this area and this area together. Right, okay. So, area between 12 and 20. Area between 12 and 20 plus area between 20 and 24. Time, basically, right? So, right, okay. So we have 1.6 times by 8 plus 20 and 24, 2.8 and 4. Right? So 1.6 times by 8 plus 2.8 times by 4, so this would be 24. Okay. Find an estimate of the median time spent working in this week. So for the median, what we need is to understand where the half of 64 would be. So it's just like the frequency, group frequency table basically. So 64 divided by 2 is 32. We need to see where it comes out. So 10 times by 0.5, this is 5. We can delete this now. So 10 times by 1.6, 16. 5 times by 2.8, 14. 5 times by 3.4, 17. So 32, let's see, 5 plus 16 plus 14, this is 35. So it's in between this region, right? So between 20 and 25. Right. So up until this, the frequency has become 21. After this, it would be 21 plus 14. This would be 35. Right. So if we draw that linear interpolation line over here, so for the frequency, you have 21, 35, Q2, oh no, sorry, no. This is the frequency. So this is 32. Right. And for the time we need, so between 20, Q2, and 25. Right. Now we can do that. So Q2 minus 20 over 25 minus 20 equals to 32 minus 21 divided by 35 minus 21. Right? Is it 35? Yeah, 35 minus 21. Right, okay. So Q2 minus 20 divided by 5 equals to 32 minus 21, that is 11 over 14. Right, so 32 minus 21, 11, and 35 minus 31 is 14. Right, okay, so 55 divided by 14 plus 20, 23.928, so you can round it as 24.0. Right, okay. Charlie decides to model these data using a normal distribution. Charlie calculates an estimate of the mean to be 23.9 hours to 1 decimal place. Comment on Charlie's decision to use a normal distribution. Okay, so we use normal distribution if we can see the mean is at least close to the median and mode. So median and mode. Only then we use that. So since we don't know the mode, we can make the decision on basis of mean. So we figured out the median to be 24 or 23.9. So yes, we can do that. Actually, we can just keep it as 23.9. Sorry, 23.9. Right. So the last part, since mean is approximately equal to median, the normal distribution can be used. Normal approximation can be used. Normal distribution can be used to model the data. Can be used to model the data. Right, okay, so this part was D and C. Right, so this was this question number 5. Let's move on to question number 6. Question number 6. A biased die with 6 faces is rolled. The discrete random variable x represents the score, which is the uppermost. Cumulative distribution function of x is shown in table below. Find the value of the constant k. So remember, in the cumulative frequency distribution, the last one will be equal to 1. So k is basically just 1 over 10. So 10k equals to 1. Therefore, k is either 1 over 10 or 0.1 depending on your taste. Find the probability distribution of x. So you can see that this would be 0.3, 0.5, 0.7, 0.1. So going from over here to over here, this is not a big jump. So probability of x would be 0.1, and since the sum over here is 0.2, 0.2 minus 0.1, 0.1, 0.3 minus 0.2, 0.1, 0.2 because it jumps 0.2, then 0.2 further again, and then 0.1. So if you sum all of them, 0.4, no, wait, 10 times by 0.1, oh sorry, this is supposed to be 0.3, my bad, sorry, this is supposed to be 1, my bad, right, okay, so the probability distribution of x, we need to make a table. So that's it. B, we have x, probability of x, so the first two were 0.1, 0.1, 0.1, 0.2, 0.2, 0.3. This was the pattern, right? Yeah, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And that's your probability distribution table. So we can trim this now. Right, okay, moving on. And a biased die with 8 faces is rolled. Now it's 8 faces. The discrete random variable y represents the score, which is the uppermost. The probability distribution of y is shown in the table below, wherein we are constants. Given that expectation of y is 4.02, form and solve two equations in A and B to show that A is 0.15, 0. You must show your working. Right, so okay. So one equation will come from the sum of all the probability of y equals to 1, and the other one will actually come from the expectation. So we have, going back, 3a plus 3b and 0.11, 0.05. 15, right? 0.5, sorry, 0.5. Right, this is equal to 1. So we go 3a plus 3b equals to 1 minus 0.11 minus 0.05, 0.84, and then we divide all of this by 3 to make it into a plus b equals to 0.28. This is our first equation. Now we make the equation in terms of expectation of y. So we have 1, 2, 3, 4, 5, 6. So A plus 2A plus 3A plus 4B plus 5B plus 6B plus 7 times by 0.11 plus 8 times by 0.05. Right, so this becomes 6A plus 9 plus 6, 15B plus 7 times by 0.11 plus 8 times by 0.05, so that is 1.17. This is equals to 4.02. Right, okay, now we simplify this further. This becomes 4.02 minus 1.17, 2.85. Is 2.85 divisible by 3? 0.95, okay. Okay, so 3, no. Okay, so we could have done 2.85 divided by 6 also, since it doesn't matter really. You would get 475 over here, A, and 15 divided by 6 to be 2.5B. Right, okay, now this is our second equation. So now we solve two equations. A plus B equals to 0.28. A plus 2.5B equals to 0.475. Actually, we needed A, but never mind. We can solve it again. A minus minus. So this cancels out. Minus 1.5B equals to 0.475 minus 0.28 minus 0.195. So therefore B is this divided by 1.5, 0.13. A would be 0.28 minus 0.13. Sorry, 28 minus 0.13, 0.15. And I think that's what we needed to show, right? Oh, thank God, yes. Now show that EY squared is, expectation of Y squared is 20.7. Right, okay. So first off, we need to write the values that way. Now, this is going to be part D, okay. This was part C. Okay. So now we need the Y squared. And the probability of Y. So you have 1, 2 would be 2 squared, 9, 16, 25, 36, 49, 64. Now we need the values, actual values. So first let's write in the A and B form, so we can convert it later on. So A, B, 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 0.11, 0.05. So A we have found to be 0.15, 0.13, 0.13, 0.13, and this is staying as it is. Okay, so expectation of Y squared is 0.15 times by 4 times by 0.15 plus 9 times by 0.15 plus 16 times by 0.13 plus 25 times by 0.13 plus 36 times by 0.13 plus 49 times by 0.11 plus 64 times by 0.05. Okay, now we need to write 0.15 plus 4 times by 0.15 plus 9 times by 0.15 plus 16 times by 0.13 plus 25 times by 0.13 plus 36 times by 0.13 plus 49 times by 0.11 plus 64 times by 0.05. So 20.7, and that's what we needed to show. Right? Okay. Find variance of 5 minus 2y. Okay. So remember, this is now another variable. So the variance would just be this 5 minus 2y would just be basically 2 squared variance of y. Right? Variance is basically the square root. Square root of standard deviation is already supposed to be a square, so we can't use the negative. So E, variance of 5 minus 2y is just simply equal to 2 squared times by variance of y. So this means we need to find out the variance of y first. That is going to be E y squared minus the square of expectation of y. So this is 20.7 minus the square of expectation of y, which was given as 4.02, right? Squared. So 20.7 minus 4.02 whole squared, sorry, 4.5396. Variance of 5 minus 2y would be 4 times by 4.5396. This times by 4. You get 18.1584, and you can round it to 18.2. Okay. These dice are rolled once. The scores on the two dice are independent. To find the probability that some of these scores are independent. So these dice, the 6-faced die and the 8-faced die. Find the probability that sum of these scores is 3. So it can only happen if you get 1, 2 or 2, 1. Right? That is the only way this can happen. So let's probability of x plus y equals to 3 can only be if x is equal to 1, and since they are independent, so we can do that. 2, or it can be x is equal to 2 and y is equal to 1. Is 3, right? Is 3 or at least 3? Right, okay. So since they are independent, the combined probability would be product of those two, right? So this is 0.15 and this was 0.1. Okay. No. 0. Actually, both of them are 0.1 and 0.15, 0.15. Okay. So 0.1 times by 0.15 and 0.1 times by 0.15. So plus. So basically 2 times by 0.1 times by 0.15. So 2 times by 0.1 times by 0.15. That is 0.03. Okay, so that's it for this question. Let's move on to the question number 7. Question number 7. A box contains only red counters and black counters. There are n red counters and n plus 1 black counters. 2 counters are selected at random, one at a time, without replacement from the box. Right, so this is a dependent case. Complete the tree diagram for this information, give your probabilities in terms of n where necessary. Okay, so total counters are n plus 1 to n plus 1. However, they are going to get reduced over time. So n red counters, so the first one is n divided by 2n plus 1, and the first time n plus 1 divided by 2n plus 1. But when one red has been taken, this will become n minus 1 over 2n, but number of black would remain the same. Similarly, if the black has been taken first, so red would remain the same, so n over 2n, but this would become n over 2n also. Right? Okay. Show that the probability that 2 counters selected are different colors are this. Okay, so different colors would mean red black or black red. So we need to add these. Probability of R black or black R. So this is wait, what was it? N times by n plus 1 2n plus 1 2n plus n plus 1 times by n and 2n plus 1 times by 2n. Right, okay. So as you can see, this n and this n can get cancelled, this n can, and this n can get cancelled. This is basically like a half and half situation, so this would become just simply n plus 1 divided by 2n plus 1. Right. Okay. Probability that two counters selected different colors is 25 over 49. Find the total number of counters in the box before any counters were selected. So basically we need 2n plus 1. Okay, so first we need to find n. 25 over 49. So this n plus 1 over 2n plus 1 is 25 over 49. Right, okay. So cross multiply. So 49n plus 49 equals to 25 times by 2n, that is 50n plus 25. So this would be n 49 minus 25, 44. So therefore total number of initial counters is equal to 2n plus 1, so 42 times by 24 plus 1, so 48 plus 1, 49. Right. Okay. Given that the two counters selected are different colors, given that the two counters are selected are different colors, right? So this is now condition. Find the probability that the first counter is black. So it's going to be this one divided by the total probability. Okay, so we must show your working. We must show the working. Wait a second. This was the C part. What was the B part then? This was the B part. No, wait. Yeah, this was the B part, and this is the C part, and the D part now comes. Right, okay. So probability of black red, given that it's either black red or red black. So black red was n times by n plus 1 divided by 2n plus 1 divided by 25 over 49. Okay, so we have 24 times by 25 divided by 49. So divided by 49, 49 will get cancelled. So wait a second. No. There's something we missed out. Different colors is 25 over 49. No, wait. Okay, so if we have figured out that n was 24. Oh, sorry, my bad. I actually forgot about the to win part. Oh, sorry, I was right. Okay, so the okay, let's write it in the number form so I don't forget. This is the 24 plus 1. This is 25 over 49, and this is 24 over 48. Okay, now it makes sense. Okay, so 25 over 49 times by 24 over 48 divided by 25 over 49. So as you can see, 25 over 49 gets cancelled, leaving us with 24 over 48, which is basically just 1 over 2. Right. And that's the end of this paper. I hope you enjoyed solving this paper with me. If you have any questions, feel free to reach out in the comments. If you would like us to do any specific paper, a specific question, a specific topic, also please request us in the comments. I would love to hear your feedback also. If you like this video, give it a thumbs up, subscribe to our channel, and turn on the notifications for future updates. Until the next video, take care of yourself. Bye-bye.